All right, today we are going to go ahead and do a little bit of review on water and some properties of water that we've been working on. So water has some pretty amazing properties that makes it essential for life, and some of them include these words. What I'm going to be doing is here to drawn out water molecules, but here is also one water molecule. And what we have is the red represents oxygen and the two whites represent hydrogen, okay? Remember, H2O is water, so H2 means two hydrogens and one oxygen. So water is a polar molecule. What this means is that this water molecule has an unequal share of charges. The hydrogens are positive and the oxygen is negative. One way that I remember that the hydrogen is positive and the oxygens are negative is by thinking about your grades. Is it positive to have a high grade or a low grade? It's positive to have a high grade. So hydrogens are positive. It's negative to have a low grade. So oxygens are negative. So that's an easy way that you can remember that hydrogens will always be positive and oxygens will always be negative. The next thing I want to talk about is covalent versus hydrogen bonds. So covalent bonds are two nonmetals sharing electrons, and ionic bonds are nonmetal plus a metal. Covalent, think co-captain, think co-pilot, think co-teacher. They are a pair that shares responsibilities or shares electrons. So oxygen is negative, remember low grade with an O, high grade, positive. Hydrogen is a nonmetal. Oxygen is a nonmetal. So this bond in one water molecule is a covalent bond. So one H2O holds H2 plus O, okay? So that's a covalent bond. Now, a hydrogen bond is different. We never just get one water molecule. That would be extremely unsatisfying when you reach for your glass of water. However, we do have water molecules combined. When more than one water molecule is combined, it's considered a hydrogen bond. So one water molecule is covalently bonded. More than one is hydrogen bonds. So multiple H2O is hydrogen, okay? So this bond right here is a covalent bond. This bond right here is a hydrogen bond. Now, let's talk about charges. We have an oxygen molecule, another oxygen molecule, and I'm trying to put them together. Notice that when I try to put H to H, it doesn't work. Notice when I try to put O to O, it doesn't work. Well, O to O would be negative and negative. H to H would be positive and positive, and they are repelling each other because opposites repel. I'm sorry, the same things repel. So positive and positive don't like each other. Negative and negative don't like each other, but when you get positive and negative, they do like each other. Because remember, when people are talking about dating, opposites attract. So that is why when I'm connecting these two water molecules, it has to go from hydrogen to oxygen or oxygen to hydrogen. If I drew this line from oxygen to oxygen, it wouldn't bond. If I drew this line from hydrogen to hydrogen, it wouldn't bond. Last two words, cohesion versus adhesion, okay? Cohesion, you're going to get this confused with covalent. Remember, covalent is a bond. Cohesion is gluing. Think of like adhesion. You're adhering something. You're gluing something to something. So cohesion is any time that you have water sticking to water over and over and over again. So cohesion are two of the same molecules, two or more sticking together. So water plus water, or you could think same molecules attract. Same molecules attract. Adhesion is different. Adhesion would be water sticking to something else, like this right here, okay? Or I guess it's not magnetic, so we're going to have to find something else. Water sticking to anything else would be adhesion. So when this water molecule sticks to the sheet, when this water molecule sticks to anything metal, when this water molecule adheres to something for capillary action and allows it to go against gravity, that is an example of adhesion. So this would be water attracted to a different type molecule. Let me know if you need anything else. Thanks, guys.